Hi everyone, my name is Deepika Borgaonkar. Currently I am working as assistant professor in VNR VJIT College in CSC Data Science Department. Today I am going to discuss about the data structures. It is the introduction session about the data structure. So today's we will discuss about the introduction to data structure, types of data structures, arrays and stacks. So basically what is data structure? What is data? Data is the raw information which is provided by us. So how to efficiently store that data into the computer and how efficiently we have to retrieve that particular data from the computer within a very limited time. Every time we have to concentrate about the algorithms and time complexity should be minimum. So in data structure, we will concentrate how efficiently we have to store our information and how efficiently within very limited time we have to retrieve our information from the computer. Because nowadays in every organization, in company or colleges, there are the huge amount of data. So many students' data, so many faculties' data, so many employees' data we need to maintain. So how efficiently we have to retrieve the data within a very less period of time. So that is the data structure. So it is a logical way to storing the data and mechanism to retrieve the data. Okay, how efficient way we will store and organize our data in a computer system. These are the types of data structure. Basically there are two types of data structure, primitive data structures and non-primitive data structures. So here primitive data structure is integer, float, character, double and pointer. So all these are the predefined data structures which already define. Integer will contain all the integer types of value, float will contain all the real type of value, float type of value, character will contain all the characters type of value, ABC in the form of ABC and characters form, double it will contain a little bit large values, and pointer it will contain the address of the variables. Coming towards the non-primitive data structure, again it is divided into two parts, linear data structure and non-linear data structure. So linear data structures are arrays, stack, queues and linked list. So linear data structure, it will store in the sequential form. It is stored in a linear form. So that's why it comes under linear data structure. Coming towards the non-linear data structure, it's a tree and graph. So non-linear data structure means it will generate the hierarchical format. It is not a sequential form. So that is called as non-linear data structure. So actually the entire data structure subject, these are the syllabus of data structure. Unit wise, one by one, we will discuss about all these non-linear data structures and non-linear data structures. Okay, so unit wise, array, detailed description of array, stack, queues, linked list, and after that trees and graph. So this is entire syllabus of our data structure. What are the major operations we can perform over data structure? So whatever data structure you can select, either array, linked list, queues, stacks, tree, graphs, we can perform. These are the major operations which we can perform over data structures: searching, sorting, insertion, updation and deletion. So searching means if I want to search any particular element, if I want to search a particular employee data, so I can apply the search operation. Sorting, if I want to arrange all data in a ascending or descending order, like suppose students, I want to arrange all the student name according to the roll number wise. So I will apply the sorting. There are so many sorting algorithms are there: insertion sort, selection sort, heap sort, bubble sort, quick sort. So in further classes, we will discuss one by one each and every sorting algorithms also. After that insertion, we can insert the data. Updation, we can update the data. Suppose any new employee came, so we need to insert the information of new employee. We can update the information if suppose our employee got promoted, so we need to update the information of employee. And deletion, if suppose any employee are resigned, so we need to delete the information of the employee. So every time data is required, updation, insertion, updation, deletion. So all these things we can work over in data structure. So in data structure, we will see how efficiently we can insert data, update data, delete data, how we can perform the searching operations, sorting operations over data, all these things. So first we'll start with the linear data structure. The linear data structures are array, stack, queues and linked list. So first we'll discuss about the array. The array is the fixed sized element, like fixed sized data. It contains the sequential data structure and contiguous memory allocation. So here we have to allocate the size of array first only. Predefined only we have to give the array size. Okay, and this is the structure of array. The 0, 1, 2, 3, 4 are the indexing of array, and the elements 78, 45, 12, 89, 56, these are the value which we can store inside the array. And the 48,252, this is the address where the data is stored inside the computer. That is the address of your element. So here see the address, you can observe 52, after that 54, 56. So there are 2 bytes different. That means the array size, the size of integer is here, they are considering 2 bytes. So that's why in this way array will store inside the computer. Okay, and sequential contiguous memory allocation. If suppose I want to store 10 data, so I want 10 contiguous memory to store my array elements. Here the array size is 5 because indexing start from 0. So 0 to 4. So 5 elements we can store in this particular array. We'll see what are the advantages and disadvantages of array. So array, as I told, the advantages of array, the single name we have to use. A of 0, A of 1, A of 2. The single name is enough to store 5, 10, 15 elements into the array. And we can implement stack, queues and trees with the help of array also. And 2-dimensional array is used to represent matrix. Even I want to store the graph, that is also I can store in the form of 2D matrix. So these are the advantages of matrix. Coming toward the disadvantages, so first only we have to give the size of the array. Suppose 10 elements, 15 elements I want to store. So first only we have to define the size of the array, which is quite difficult because sometimes we used to extend our array size. So it is difficult later on to extend the array size once you decided. So or if suppose I will give 100, but I am using only 10 elements. So that is also memory wastage. Okay, 90% memory I am wasting. So this predefined condition is little bit coming towards the disadvantage of array. First only we have to define the array. After that, array are stored in contiguous memory allocation. If suppose I don't have 100 memory space, I can't store that particular array. So these are the disadvantages, and it is little bit time consuming. The insertion, deletion, all these processes are time consuming in array. Now next, coming toward the stack. Stack also linear data structure, and it is based on last in first out principle. Okay, so last in first out means the element which is inserted last, it will delete it first. That rule we can't change. Stack completely based on last in first out concept. So to perform this insertion and deletion operation, we required one top end. Okay, so insertion from top end and deletion also we have to perform from top end. So these are the examples of stack. Suppose the cards and the plates. So how we will take the plates? We will take only the topmost plate. We should not take the middle plate or down plate. Otherwise all plates will be fell down. So like that only the stack, whatever it is just like an array. But in array, the difference between array and stack, we can insertion and deletion should be from top end in stack. Stack also, if we are implementing by using array, we have to define the capacity of our array or stack. Suppose 10 elements I want to store in the stack, or 20 elements I want to store in the stack. The capacity we have to define first only. Stack we can implement by using array also and linked list also. So in further videos, we will see how to implement array by using array and by using array or linked list. These are the operations we can perform over stack. So we can perform the terminology, whatever we are using. These are the terminology we are used for the stack. So if I want to insert any element into the stack, I will use push operation. If I want to delete any element from the stack, I will use pop operation. If I want to check my stack is empty, I will use is empty condition. If I want to check my stack is full, I will use is full operation. Before deletion or insertion, if I want to check what is the topmost element into the stack, so I will use peek operation. If I want to count how many elements are there into the stack, I will use count operation. If I want to display the element, I will use display operation. So these are the basic operations which we can perform over stack: push, pop, is empty, is full, peek, count, and display. So how to use push operation, how to insert element into the stack. Before insertion, we need to check our stack is overflow or is full condition. If my stack is full, we have to return the stack is full. We can't insert any elements further into the stack. And every insertion, my top element will be increment by 1, top plus 1. And when we will reach the max size, first only we have to declare, suppose size is 5. If we will reach up to 5, then I have to show my stack is full. So these are the steps to perform push operation. We'll see with example. So suppose here initially my stack is empty and top is by default initialized with -1. When I will insert one element, suppose I inserted push 10. So I inserted 10, I want to insert 10 into the stack. So 10 will be inserted into the stack and the indexing will be 0. Here also it will follow the same array concept because we are implementing by using array. So here indexing will start from 0, 10 will be inserted into the stack. Again, and top value will increment by 1, so it will be -1 to 0. Now again, next push operation, if suppose push 20, so again top will be incremented by 1 and top value will be 1 now, and the indexing will be 0 and 20 will be stored at 1 index. Again, if I will perform push 30, so 30 will be inserted into the stack, top value will increment by 1, so now 30 will be stored in second place. Okay, so 0 filled, 1 filled, and second place 30 will be stored. Again, suppose if I will insert 40, so top value will increment by 1 and the value is 0, 1, 2 and 3. At third place 40 will insert. Suppose my array size is up to 4. So 0 to 3, indexing will be taken by 0 to 3. Okay, so here we need to check if the top value is size -1, then my stack is full. If further I want to push any elements into the stack or I want to insert any element into the stack, it will display your stack is full condition. Now coming towards the delete, how to delete elements from the stack. So for deletion we required pop operation. So in pop operation we need to check if my stack is empty. If stack is underflow, stack is empty, we can't delete any element because already stack is empty. Element deletion also should be start from top element only will be deleted first. So here every deletion top will be decrement by 1. Whenever you are deleting element, top will be decrement by 1. So these few steps we need to remember. Easily we can perform insertion and deletion operation into the stack. So suppose my stack is full condition, already I inserted 10, 20, 30, 40. Top value is 3 at present. If I perform pop operation, so top value will be decrement by 1, it's 2, and 40 will be deleted from my stack. Okay. After that again I perform pop operation, so next delete will be 30, 30 will be deleted and top value will be again decremented by 1. So previously 3, after 2, after that 1. So every deletion, every pop operation value will be decrementing by 1. When we will reach here, like top value will be 0, again we are deleting next element. So 20 will be pop out from the stack. Again 10 will be pop out from the stack, and when top value is -1, then stack will be empty. If suppose again I perform pop operation, so it will display underflow condition or it will display stack is empty. So these are the basic operations which we can perform over stack and queues. Thank you so much, and in next video we will discuss about the how to implement this stack in C programming, and queue operations, what is the queue, how to insert and delete into the queue, and implementation of queue. Thank you so much.
Like, share, comment and subscribe VNR Digital Learning Resource YouTube channel.